So in Foundations Math 20, Chapter 8, let's go over the frequently asked questions, kind of like our review here. So what did we do this chapter? Well, if we go all the way back to the beginning of the chapter, what we first started talking about was like what are scale diagrams, scale models, what are they used for? So obviously if we are trying to make a model of something that is extremely large, like a plane or something, a model would be a reduction or a smaller version of the real thing. And the important thing is scale diagrams have all of the exact same, it's the exact same shape. So all of the dimensions are proportional. So either it's, it's 1 to 2, or it's 1 to 5, or it's 7 to 1, or whatever. So those scales, every single dimension is proportional the same way. So, for example, here to create a model of a train using a scale ratio of 1 to 40, you multiply every linear measurement of the train by a scale factor of 1 over 40, right? Or 0.025. So if the train is 100 feet long, right, then you multiply 100 feet times 0.025 and you get the model of 2.5 feet, about this. Does that make sense? So you multiply every dimension by the scale factor. If the number is between 0 and 1, okay, or less than 100%, then that's a reduction. That means that the diagram or the model is smaller. Okay. Any questions about scale diagrams, scale models, what they're used for? Okay. Okay, so I'll let you finish reading that if you need to. So question number 2 says, how are the areas of two similar shapes related? Well, if we take a look at a 2D shape like this, like these circles here, we could find the areas of each of these and find out how they're related. And what we found was that the areas are related by the square of the scale factor. Okay? So the scale factor here between these two, what's the scale factor between those two circles? It is what? 3, okay? Because if this one is 1, now let's say this is the original on the left. If this one is 1, the radius is 1. Over here, the corresponding measurement, that is the other radius, is 3. So it's a 1 to 3. The scale factor is 3. Every dimension, you would multiply by 3 to get the length of the dimension on the new one. And so the area, okay, is related by 3 squared. That means if this area right here, so pi r squared, the area is pi. Okay? Pi r squared is the area of a circle. So pi times 1 squared is pi. That's the area of this circle. The area of this one would be pi r squared, or pi times 3 squared, which would be 9 pi. So the factor between pi and 9 pi is 9, which is 3 squared. Okay, so if we're comparing areas of similar objects, the area of the smaller one would be, or the original one would be times k squared to get the model or the similar shape. Okay? Any questions about that? Area k squared. Okay. Now the other thing and again, this was basically the third really major component here is the volume part, right? And so if we take a 3-dimensional object, the relationship between the volumes of the original object and its model, right, or its representation, would be k cubed. So remember that volume is units cubed, right? 3 dimensions, really, that you have to multiply for something like this. So it's cubed. Okay? Now you can use the fact that we have this relationship, k cubed. You can use that to find k, obviously. We've done questions like that. Then you can use k to find the relationship between the surface areas. We did that, right? So k is the scale factor, and that's all a part of this. All right. And finally, if you know the surface areas or volumes of two similar objects, you can determine the scale factor. So that's what we were saying. If the ratio, if you know the ratio between the surface areas, well, you take that ratio and then you square root it to get the scale factor. If you know the ratio of the volumes, well, you take that ratio and you cube root it to find the scale factor. So that's kind of that's the last part, and we did some questions there in 8.6 on that. Okay? Now that's the summary. That's the chapter review. Those are the sort of the four main questions that we answered and things that we talked about. So does anybody have any questions about anything from chapter 8 that you need a little more explanation on? Any terms that you don't understand, or any examples that you need that you want to see? All right, so that's the review for chapter 8.